Pathophysiological Clarification of Vascular Calcification, number 1420, September 4, 2025. Gerald C. EclaireMD Foundation. Category: Vascular Calcification, CVD and Stroke. Abstract: Vascular calcification, VC, is a hallmark of arterial aging, and a major determinant of cardiovascular and cerebrovascular diseases, including stroke. Both diabetes and hypertension are well-recognized contributors. However, longitudinal and mechanistic studies suggest that diabetes exerts a more systemic and progressive influence, whereas hypertension serves mainly as a mechanical amplifier or final trigger of acute events. This paper is the first in a four-part series, examining vascular calcification through pathology, physiology, and epidemiology. The goal is to clarify why diabetes and hypertension are the two primary forces driving vascular calcification, and to explain their distinct yet interconnected roles in vascular aging and disease progression. Introduction. Arterial calcification represents the final stage of chronic vascular injury. On CT imaging, calcified arteries appear as bright white areas, reflecting the loss of vessel elasticity. This rigidity elevates pulse pressure, PP, and increases the risk of stroke, heart failure, and kidney disease, particularly through microvascular calcification. Although both diabetes and hypertension contribute to VC, their underlying mechanisms differ. Diabetes, a metabolic disorder, promotes medial calcification through biochemical and metabolic injury. Hypertension, a hemodynamic factor, accelerates intimal calcification through repetitive mechanical strain. Understanding the relative influence of these two mechanisms is critical for effective disease management and prevention. Current imaging methods, such as CT calcium scoring, are expensive and unsuitable for continuous monitoring. Therefore, developing a quantitative and data-driven model to assess calcification dynamics without imaging is both practical and necessary. This paper, number 1420, provides a pathophysiological explanation of vessel calcification, VC, forming the foundation for the following three studies: the viscoplastic medicine theory, VMT, model, the topological data analysis, TDA, model, and their comparative synthesis. Methods. 1. Mechanistic foundation. Diabetes-driven calcification. Chronic hyperglycemia damages the vascular endothelium through oxidative stress and non-enzymatic glycation. Over time, this process generates advanced glycation end products, AGEs, which bind to collagen and trap calcium and phosphate within the vessel wall. These deposits stimulate smooth muscle cells to transform into bone-like cells, creating hard, mineralized tissue in the medial layer, a process known as Munkeberg sclerosis. Once initiated, this calcification process becomes systemic and largely irreversible, affecting arteries that supply the heart, brain, and kidneys. This explains why organ damage is only partially reversible, even after glucose control improves. In summary, pancreatic insulin impairment and sustained hyperglycemia serve as the primary drivers of vascular calcification in diabetes, gradually turning flexible arteries into rigid, mineralized structures that increase the risk of heart disease, stroke, and kidney failure. In this series, I use the average of two parameters: visceral fat percentage, VF%, and early morning fasting plasma glucose, FPG, as the two key metabolic indicator. Hypertension-driven calcification. Chronic high blood pressure places repeated mechanical stress on arterial walls, causing intimal thickening and plaque formation. Over time, calcium accumulates within these plaques, producing localized stiffness and loss of elasticity. Hypertension therefore worsens existing damage, rather than initiating calcification independently. In this study, two blood pressure parameters are used as hemodynamic indicators. PP is SBP minus DBP, reflecting vessel stiffness. Mean arterial pressure, MAP, is DBP plus PP divided by 3, representing the average effective pressure for oxygen and nutrient delivery. 2. Literature support. Medical and imaging research identifies two major types of vascular calcification. Medial arterial calcification, MAC, occurs in the middle layer, and is strongly linked to diabetes and chronic kidney disease. It causes arterial stiffness, elevated pulse pressure, and long-term organ damage. Intimal calcification, IC, occurs in the inner layer, typically driven by hypertension and mechanical stress, which narrow arteries and trigger acute events such as heart attacks or strokes. Large population studies, including the MESA, multi-ethnic study of atherosclerosis, show that diabetes and metabolic syndrome, a cluster involving high blood sugar, excess body fat, and abnormal cholesterol, are much stronger predictors of both the development and progression of coronary artery calcium, CAC, than blood pressure alone. When scientists aggregate data through meta-analyses, they consistently find that diabetes is the dominant cause of vascular calcification, and a strong predictor of cardiovascular mortality. Hypertension acts primarily as an amplifier, worsening the vascular injury, already initiated by diabetes. 3. Mathematical model, vascular calcification risk proxy, VCRP, to estimate calcification risk without CT imaging. 4 measurable variables are used. pp is 45 mm of mercury, MAP is 85 mm of mercury, FPG is 90 mg per deciliter, VF is 13%. Each variable is normalized to its healthy reference value. NPP is PP divided by PP star, NMAP is MAP divided by MAP star, NFPG is FPG divided by FPG star, NVF is VF% divided by VF star. 2 components are then calculated. Metabolic component is 0.26 times NPP plus 0.24 times NMAP. Hemodynamic component is 0.28 times NFPG plus 0.22 times NVF. The vascular calcification risk proxy, VCRP, is then derived as VCRP is metabolic plus hemodynamic. This model allows long-term, quantitative tracking of vascular calcification risk, using simple daily biomarkers, eliminating the need for repeated CT or imaging scans. 4. Interpretation of VCRP. Less than 40 equals low risk, from 40 to 79 is moderate risk, 40 to 79 equals moderate risk, 80 to 119 equals high risk, greater than or equal to 120 equals very high risk. My calculated VCRP values were above 120 from 2010 to 2012. 152, 2, 130, indicating a very high level of vascular calcification risk. After that initial period, the values gradually declined from 115 in 2013 to 99 in 2025, reflecting a steady improvement in overall vascular condition. Nevertheless, despite this long-term recovery, the cumulative vascular calcification and structural damage that developed during those earlier years likely contributed to my stroke event on June 21, 2025. The VCRP index differentiates metabolic and mechanical influences on vascular stiffness. In longitudinal data, FPG and VF% represent my chronic metabolic stress, while PP and MAP reflect my hemodynamic load. Discussion. Dominant role of diabetes. CT scans can show where and how much calcification exists in the arteries, but they cannot explain why it formed. Only pathology can determine whether the cause is metabolic, such as diabetes, or mechanical, such as long-term hypertension. Persistent hyperglycemia, through ages and inflammation, permanently alters smooth muscle cell function, and drives mineralization throughout the arterial system. According to all the studies and clinical data currently available, most of the proof that diabetes contributes more strongly to vascular calcification than hypertension comes from statistical or epidemiological studies, not from quantitative or mechanistic measurements. The GH method, viscoplastic medicine theory, VMT, provides this missing quantitative bridge by expressing metabolic and hemodynamic stress as measurable strain-stress-energy relationships, enabling direct comparison of their true physiological impacts. Role of hypertension as amplifier. Hypertension intensifies pre-existing metabolic damage by increasing arterial wall tension. It accelerates calcium buildup in already weakened vessels, but rarely causes calcification independently. Thus, hypertension acts primarily as a load multiplier on a metabolically compromised vascular system. Synergistic interaction. When both diabetes and hypertension coexist, their effects multiply. Diabetes weakens vessel walls biochemically, while hypertension aggravates them mechanically. This dual stress accelerates vascular aging and dramatically increases the risk of stroke, myocardial infarction, and chronic kidney disease. Conclusion. Diabetes, through sustained hyperglycemia and glycation, stress, is the main systemic cause of medial vascular calcification. Hypertension functions primarily as a mechanical amplifier, accelerating calcium deposition in already damaged areas. When both coexist, their synergistic interaction leads to faster vascular degeneration and higher mortality risk. Reference articles. The following 6 published papers together provide a solid foundational base for supporting my central argument that metabolic influences, diabetes, hyperglycemia, metabolic syndrome, exert a stronger and more systemic impact on vascular calcification than hemodynamic influences, hypertension, pressure load. 1. Yao H. et al. Epidemiological Research Advances in Vascular Calcification. 2021. 2. Petrie Jr. et al. Diabetes, Hypertension, and Cardiovascular Disease, Clinical and Mechanistic Insights. 2018. 3. Nickel R., Zhao Y., Ibrahimi P., Olive Krona G., Henane M. Diabetes and hypertension consistently predict the presence and extent of coronary artery calcification in symptomatic patients. A systematic review and meta-analysis. Int. J. Mol. Sci. 17,9,1481, 2016. 4. Lanzer P. et al. Medial Arterial Calcification, Jack State of the Art Review, J. M. College, Cardiol. 2021, 5. Stabley J. N., et al., Arterial Calcification in Diabetes Mellitus, Arterioscler, Throm, Vosk, Biol. 2017, 6. Lee Q., et al., Association of Diabetes with Cardiovascular Calcification, and All-Cause Mortality in End-Stage Renal Disease, in the Early Stages of Hemodialysis, a Retrospective Cohort Study, Cardiovasc, Diabetal, 23259, 2024. Disclaimer: I write this paper not for fame, but to share what I have learned so others can understand their health, prevent disease, and live longer, healthier lives. This content is provided for educational reference only, and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article, and its related materials belong to the author, Gerald C.